Okay, Assalamualaikum. Still in the second chapter, statistical method, chi-square test, and for this e-lecture, we will discuss one more um, use of chi-square distribution. Um, so we will use the chi-square test using the contingency table. If you are given the contingency table, what kind of test that we can perform with that type of data. Okay, now when data can be tabulated in a table form in terms of frequencies, several types of hypotheses can be tested by using the chi-square test. Okay, two such tests are the independence of variable test and also the homogeneity of proportion test. Okay, so the test of independence of variable is used to determine whether two variables are independent of or related to each other when a single sample is selected, and the test of homogeneity of proportion is used to determine whether the proportion for a variable are equal when several samples are selected from different population. Okay, so for this lecture I will focus on the first part, which is the test of independent of variables. Okay, uh, this is one example. Suppose a new post-operative procedure is administered to a number of patients in a large hospital. Do doctors feel differently about the procedure from the nurses, or do they feel basically the same way? So it's the question. And now we have one set of data. There are two groups, nurses and doctors, and we have three um, preference. Either prefer new procedure or old procedure, or maybe there's no preference from nurse or doctors. Okay, the question now is the question that we have to answer. Do the doctor feel differently about the procedure from the nurses, or do they feel basically the same way? So, or in another word, is it the feel, okay, the choice of doctors and nurses independence? So first step, you have to state the null hypothesis and also the alternative hypothesis. Okay, for the null hypothesis, focus on the independent. Okay, so the opinion about the procedure is independent of the profession, and the H1, the alternative hypothesis, the opinion about the procedure is dependent on the profession. Okay, first step, we have to state the hypothesis for any hypothesis testing. Okay, second step, since we are going to use the chi-square test, the chi-square statistics is the sum of observed minus expected square divide by expected, and all the data that we have now is the observed value. Okay, all this is the observed value. Now we need the expected value. Okay, we need the expected value. How to calculate the expected value for data in the contingency table? So this is the way to calculate the expected value. So expected value is equal to the row sum multiplied by the column sum divided by grand total. Okay, that means you have to find the row sum and you have to find the column sum, then you have to divide by grand total. Okay, from this set of data, first step, you have to calculate the row sum. Okay, 100 for the first row, 100 plus 80 plus 20 is 200. So this is the row sum. Okay, the next row, 50 plus 120 plus 30 is also 200. And for the first column sum, 100, 100 plus 50. So this is 150. This is column sum. So the second column sum 80 plus 120 is 200, and the last column sum 20 plus 30 is 50. And the grand total, okay, the grand total 200 plus 200 or 150 plus 200 plus 50. So 400 is the grand total, the total number of sample, okay, among doctors and also the nurses. Alright, so after you find the row sum and also the uh, column sum, then you have to calculate the expected value for each cells. Now we have 6 cells. Okay, so the first cell, so you put the expected value in the brackets so that we can differentiate between expected value and also the observed value. Okay, for the first cell, so this is the observed one. So what is the expected value? So the row sum is, this is the row sum. Okay, so this is the row sum multiplied by the column sum. So this is the column sum. Then we have to divide by grand total. Grand total is 400. So 200 multiplied by 150 divide by 400 is 75. So 75 is the expected value for the first cell. Okay, for the first cell, 75 is the expected value. Okay, now we move to the second cell. So the second cell, the row sum is 200 multiplied by the column sum is 200. Then you have to divide by 400. So the expected value is 100. Alright. Then settle for the second cell. We move to the next cell. 200 multiplied by 50 divided by 400. So the expected value is 25. Okay. For the next row, uh, 200 multiplied by 150 divided by 400 is equal to 75. This is expected value for this cell. For the next cell, 200 multiplied by 200 divided by 400 is 100. And for the last cell, 200 multiplied by 50 divided by 400 is 25. Okay, so all the values in the bracket is the expected value, uh, and then all the original value is the observed value. Okay, now first step, you have to state the hypothesis. So we proceed to the second step. Either you find the critical value or you calculate the test statistics. Okay, since the previous example, I calculate the test statistic for the second step. So for this example, I also calculate the test statistic chi-square. Okay, where the sum of observed minus expected square divide by expected. Okay, so you have to move each cell. Okay, now we focus for the first cell. Okay, for the first cell, observed is 100, expected is 75, then square divide by expected 75. Plus, move to the next cell, the observed is 80 minus expected 100 square divide by 100. Next, the third cell. Okay. Um, for the next cell, this is 20 minus 25 square divide by 25. Next cell is here, 50 minus 75 square divide by 75, plus the next cell here, 120 minus 100 square divide by 100, plus the last cell is 30 minus 25 square divide by 25. Okay, now you just have to use your calculator, simplify, and the answer will be 26.67. So this is the test statistics value. Okay, this is the test statistic value. Then we Move to the next step. The third step, you have to find the critical value. Okay, the only different this test, okay, if the data given in the contingency table is how to calculate the expected value. Okay, how to calculate the expected value. That's the only difference between this test in the contingency table or the previous example, goodness of it, test that we have learned in the previous lecture. So critical value is chi-square alpha, and how to find the degree of freedom, since we have the data in the what we call this contingency table. So if we have the data in the contingency table, uh, the degree of freedom is the number of row minus 1 multiplied by the number of column minus 1. So it should be like this lah. Number of row minus 1 multiplied by the number of column minus 1. So this is equal to the chi-square alpha now is 0.05. The number of column, the number of row is 2. 2 minus 1 is 1. Multiplied by the number of column is 3. Okay, so the number of row is 2. 2 minus 1. And the number of column is 3. 3 minus 1. So 2 minus 1 is 1. 1 multiplied by 2 is 2. So now we have to refer to the chi-square distribution table with alpha 0.05 with degree of freedom 2. Okay, degree of freedom 2. So from the table, okay, from the table, the critical value is 5.991. Okay, this is the critical value. So from the critical value, you just sketch the chi-square distribution curve. This is the critical value 5.991, and this is the critical region. We have to reject H naught if the test statistic fall in this area, and now the test statistic is 26.67, which is in the critical region. Okay, which is in the critical region. That means we have to reject H naught. Okay, we have to reject H naught. That means we have enough evidence to support the claim that the opinion uh, is related to profession. Okay, so now we have to reject H naught, and you have to make the conclusion. Okay, so this is the fourth step, conclusion. So the conclusion, we can say that there is enough evidence to support the claim that opinion is related, or you can say is dependent on profession. Okay, so this is the conclusion. Okay, this is the test of independence using chi-square distribution if the data in the contingency tables. Okay, now let's try one more example. A researcher wishes to see if the gender of the person who prepares dinner is independent of the time when the person decides what to eat for dinner. A sample of 70 men and a woman is selected, and the results are shown. At alpha 0.05, can it be concluded that the variables are dependent? Okay, so first step you have to state the null hypothesis and also the alternative hypothesis. So the null hypothesis, the variables are independent. Okay, so the variables are independent, and for H1 the variables are dependent. Or it's better for you to write in the full sentence. Okay, you just can take from this question. The gender of the person who prepare dinner is independent of the time when the person decide to eat for dinner. Okay, that is our H naught. Okay, the H1 is the gender of the person who prepares dinner is dependent of the time. Okay, so in the full sentence. Okay, after we state the null hypothesis and also the alternative hypothesis, before we can proceed with the calculation of expected value, you have to find the row sum and the column sum. Okay, for the row sum, 20 plus 9 plus 10 is 39. For the second row, 16 plus 12 plus 3 is 31. Okay, so this is the row sum, and the column sum for the first column, so 20 plus 16 is 36, 9 plus 12 is 21, and 10 plus 3 is 13, and the grand total is 70. Okay, we have 70 samples. All right, for the first cell, to find the expected value will be 39 multiplied by 36, then divide by 70, so 20.06. Okay, 20.06. For this next cell, uh, in the morning for female, 39 multiplied by 21, then you have to divide by 70, so this is 11.7. And the last one is 39 multiplied by 13, then divide by 70 is equal to 7.24. Alright, so that's for the first row. Now we move to the second row. In the afternoon for male, 31 multiplied by 36 divide by 70, so this is equal to 15.94. Okay, next cell, 31 multiplied by 21 divide by 70, so this is equal to 9.3. Actually, you can calculate based on the total for each row. Okay, for example, the total is 13 here. Sorry, for each column, the total is 13. Now we have 7.24, so 13 minus 7.24, the remaining is here. Okay, the value for the remaining will be in the last cell. 31 multiplied by 13, then you have to divide by 70, so this is 5.76. Okay, so 5.76. All right, so this is all the expected value that we have. Okay, now we proceed to the second step. We have to calculate the test statistic. Okay, test statistic chi-square is equal to the sum of observed minus expected square divided by expected. So this is equal to 20 minus 20.06 square divide by 20.06 plus this is 9 minus 11.7 square divide by 11.7. Next is 10 minus 7.24 square divide by 7.24. Next is 16 minus 15.94 square divide by 15.94. Next is 12 minus 9.3 square, divide by 9.3, and the last cell is 3 minus 5.76 square, divide by 5.76. Alright, so you have to simplify each term. 20 minus 20.06 square, then divide by 20.06 is 0.000179123 yeah, plus 9 minus 11.7 square, then divide by 11.7, so this is 0.623, plus next is 10 minus 7.24 square, divide by 7.24, so this is 1.052. Next is 16 minus 15.94 square, then divide by 15.94, so this is 0.0002226, and then plus 12 minus 9.3 square, divide by 9.3, so this is 0.784, and the last term 3 minus 5.76 square, okay, divide by 5.76, so this is 1.323. Okay, and you just have to total up 0.784, then plus 0.0000226, plus 1.052, plus 0.623, plus 0.000179. So the answer is 3.782. Okay, so this is the value of test statistic, and we proceed to the next step. You have to find the critical value. Okay, the critical value from the statistical table. Chi-square alpha now is 0.05. The number of row minus 1, we have 2 row minus 1, multiplied by the number of column minus 1, 3 minus 1. So chi-square 0.05 with the degree of freedom 2. So this is 5.991. Alright, so from the curve here is 5.991, and this is the critical region. That means we have to reject H naught if the test statistic value fall in this region. And now the test statistic is 3 point something, okay, 3.782, which is not in the critical region. That means we fail to reject H naught. Okay, we fail to reject H naught. That means if we fail to reject H naught, okay, we fail to reject H naught, that means we have to accept H naught. Okay, we have to accept H naught. So the conclusion is the gender of the person who prepares dinner is independent of the time when the person decide what to eat for dinner. Okay, you can simply copy back this sentence, okay, for the conclusion. Right, you have to write the conclusion in full sentence. Okay, so I think that's all for this lecture. There are two more lecture for this chapter, two more tests or two more use of chi-square test that we will discuss. Okay, that's all. Thank you.